In the global race for the solid-state battery, the holy grail of EVs, we usually hear two names, Toyota and CATL, maybe BYD. But while the giants have been making headlines, another player has been quietly building an empire in the shadows. A player known as the technological man of China's auto industry. They just unveiled a battery with a staggering 600 watt-hours per kilogram energy density. They've proven it works at minus 40 degrees Celsius. They've even cut a corner off the battery cell, and it kept running without fire or smoke. And unlike others making vague promises for 2030, they are targeting mass production in 2026. Hello everyone, welcome to Volt China EV. Subscribe to master the world's fastest moving EV market before your competitors do. Today, we are revealing the secret weapon of Chery Automobile. We will dissect their multi-path technology, their bold production timeline, and ask the big question: can this silent giant actually beat the world's best to the solid-state finish line? But before we break down Chery's bold claims, a crucial insight: the solid-state race isn't just about one company. It's a complex battlefield. I've just released my BYD Solid-State Battery Report 2025, which provides a deep, comparative analysis of the entire industry's progress. While today, we focus on Chery, this report reveals the benchmarks they are trying to beat. It's packed with technical charts and competitive data that I can't fit into a single video. I've made the full PDF available for free download for a limited time. The link is in the description below. Grab it now to get the complete picture of this energy revolution. Chery didn't just wake up yesterday and decide to make batteries. This is the result of a strategy that began in 2018 with over 10 billion RMB, $1.4 billion, invested. While others bet on one horse, Chery is betting on the whole race. Their strategy is built on a 3 horizontal, 3 vertical architecture. Horizontally, they are developing all 3 major solid-state paths simultaneously: polymers, oxides, and sulfides. This is a massive undertaking, ensuring that no matter which chemistry wins, Chery wins. Vertically, they are controlling everything from material design to equipment manufacturing to system integration. They have assembled a dream team of over 1,000 experts, including a dedicated doctoral legion of 50 PhDs focused solely on breaking the solid-state barrier. This is brute force engineering at its finest. Let's talk numbers. The headline figure is 600 watt-hours per kilogram. To put that in perspective, the best Tesla battery today is around 270 to 290 watt-hours per kilogram. Chery is effectively doubling the energy density. What does this mean for you? Range. It means a real-world range of 1,200 to 1,500 kilometers. That's driving from London to Berlin or San Francisco to Seattle on a single charge. Range anxiety is dead. Speed. It supports 6C to 10C fast charging. That means adding 400 kilometers of range in just 5 minutes. It's literally as fast as pumping gas. Cold weather. This is where it gets crazy. In tests at minus 40 degrees Celsius in Mohe, China's North Pole, the battery retained 82% of its range. Standard EVs would be lucky to get 50%. This technology finally makes EVs viable for the coldest regions on Earth. But performance means nothing without safety. And Chery's solid-state battery seems practically indestructible. Because solid electrolytes aren't flammable like liquid ones, the safety margin is enormous. Chery has subjected these batteries to torture tests that would turn a normal battery into a bomb. Nail penetration, no fire, no smoke, max temperature only 48 degrees Celsius. Cutting. They literally cut off 1/8 of the battery cell with an angle grinder. The result? It kept running, powering a car for another 37 kilometers. This is what they call intrinsic safety. It's not about adding armor, It's about the chemistry itself being safe. For consumers terrified of battery fires, this is the ultimate reassurance. Technology is great, but can they build it? This is where Chery distinguishes itself from startups like QuantumScape. They are a manufacturing giant. Their timeline is aggressive but structured. 2025, now. First prototypes rolling off the line, with energy densities hitting 300 watt-hours per kilogram. 2026, small-scale directional operations. This means putting these batteries into premium fleets, likely buses or high-end SUVs, to gather real-world data. 2027, mass production begins. They are building a massive production ecosystem, partnering with lithium giant Ganfeng Lithium and others to secure the supply chain. Their goal is to slash costs to 1.2 RMB per BH, which is significantly cheaper than Toyota's projected costs. The first car to get this tech? The Lai Feng Hunting Wind concept, a futuristic shooting brake that claims to embody the pinnacle of this technology. However, we must remain objective. The path from lab breakthrough to showroom floor is littered with failed promises. Chery faces significant hurdles. Interface impedance. The solid-solid contact problem is the nemesis of solid-state batteries. Making sure the materials stick together at a microscopic level for thousands of charging cycles is incredibly hard. Manufacturing consistency. Making one perfect battery is easy. Making 1 million perfect batteries, where a single defect can ruin the pack, is a different beast. Their current yield rate is around 75 to 85%. Autograde requires 99.9%. That last 15% is the hardest. Cost. Even with their optimizations, solid-state batteries will initially be expensive. They will be reserved for premium vehicles, 40,000 to 60,000 range, before trickling down to the mass market. Chery's entry into the solid-state arena changes the game. It proves that the innovation in China's EV sector isn't limited to just one or two companies. It is a systemic, industry-wide wave. So, here is my take. Chery is the dark horse that Toyota and VW should be worried about. While the world watches BYD and Tesla, Chery has been building a vertical fortress. Their multipath strategy is brilliant, hedging their bets on different chemistries to ensure they don't miss the future. However, I remain skeptical about the 2026 mass adoption timeline. Directional operation is code for beta testing. I believe we will see these batteries in halo cars and specific fleets in 2026, but true mass market availability for the average consumer is likely a 2028 to 2030 story. But make no mistake, the solid-state era is coming, and it will likely arrive from the east. Whether it's BYD, CATL, or now Chery, the momentum is undeniable. Now, I want to hear from you. Does a 1,500 kilometer range battery sound like overkill? Or is it exactly what you need? And would you trust a solid-state battery from Chery over one from Toyota or Tesla? Let me know your thoughts in the comments below. And remember, for the ultimate deep dive into the market leader's strategy, don't forget to download the BYD Solid State Battery Report 2025 from the link below. If you found this deep dive valuable, please give this video a thumbs up. And remember, subscribe to master the world's fastest moving EV market before your competitors do. Thanks for watching, and I'll see you in the next one.